Ever wondered how you magically land on your favorite website just by typing in its name? You type youtube.com and poof, there it is. But what's the magic happening behind the scenes? Not magic. It's DNS, the domain name system, and it's basically the internet's giant, super fast phone book. Today, we're going to demystify DNS and understand why it's truly the backbone of the internet. By the end of this video, you'll have a crystal clear picture of how this fundamental technology works and why it's so critical for our daily online lives. So what is DNS? At its core, DNS translates human-friendly domain names like Google.com into machine-friendly IP addresses. Think about it. Our brains are great at remembering names, but not so much a long string of numbers like 142.250, 191.78. Computers, on the other hand, love numbers. They use IP addresses to locate and communicate with each other over the internet. Without DNS, you'd have to memorize the IP address for every single website you want to visit. Imagine trying to remember a dozen different phone numbers just to browse the web. DNS saves us from that headache, acting as the essential translator between us and the machines. To handle the billions of websites out there, the DNS system is brilliantly organized in a hierarchical structure, like a giant inverted tree. At the very top of this tree are the root servers. There are only 13 sets of these servers worldwide, and they are the ultimate authority. They don't know the exact IP address for every website, but they know who to ask next. When you request a website, the first step often involves a query to a root server. The root server will look at the end of the domain name, the part like com.org or neat and direct the query down to the next level, the top-level domain, or TLD servers. So, after the root server points the way, the query goes to a TLD server. These servers manage all the domains within a specific top-level domain. For example, the com TLD server manages every single .com website. This server doesn't have the final IP address either, but it knows the next stop on our journey, the authoritative name servers. The TLD server looks at the domain name, say YouTube and YouTube.com, and directs the query to the specific authoritative servers that are responsible for the youtube.com domain. This delegation of responsibility is what makes the DNS system so incredibly efficient and scalable. It can handle the entire internet without getting overwhelmed. Now we arrive at the final destination in our query journey, the authoritative name servers. These servers are the ultimate source of truth for a specific domain, company, or individual who owns the domain, like Google for YouTube.com, runs these servers. The authoritative server holds the actual DNS records for that domain, including the crucial A record, which maps the domain name to its corresponding IP address. Once it receives the query, it provides the final answer, the IP address we've been looking for. This process, from your computer to the root server, to the TLD server, and finally to the authoritative server, is called DNS resolution. And believe it or not, this entire multi-step journey usually happens in just a fraction of a second. But wait, if every single request had to go through this entire chain every time, the internet would slow to a crawl. This is where catching comes in to save the day. Catching is like creating a temporary memory. When your computer or your internet service provider's DNS resolver gets an IP address for a website, it stores that information for a set period of time. This is called the time to live, TTL. The next time you want to visit that same website within the TTL period, your computer doesn't need to go through the whole resolution process again. It can just pull the IP address from its cache. This dramatically speeds up browsing, reduces the load on DNS servers, and makes your overall internet experience much smoother and faster. Now let's talk about the unsung hero of this whole process, the DNS resolver, also known as the recursive resolver. This is a server, usually operated by your internet service provider, that does all the heavy lifting for you. When you type a domain name into your browser, your computer sends the request to this resolver. The resolver then acts on your behalf, going through the entire process we just discussed, querying the root servers, the TLD servers, and the authoritative servers until it finds the IP address. Once it has the answer, it sends it back to your computer. This resolver is the workhorse of the DNS system, handling the complex recursion and communication so that your device doesn't have to. It's the tireless assistant making sure you get where you need to go online. Understanding DNS isn't just for tech geeks. It's crucial for navigating our digital world effectively. For web developers and network administrators, a deep understanding of DNS is essential for managing websites, configuring email servers, and troubleshooting connectivity issues. DNS records aren't just for IP addresses. There are many types, like MX records for mail exchange, CNAME records for creating aliases, and TXT records for verification purposes. Knowing how to configure these records properly is key to a healthy and functional online presence. For the everyday user, a basic knowledge of DNS helps you understand what's happening when a website fails to load and empowers you to troubleshoot simple problems. Like by trying a public DNS resolver like Google's 8.8, 8.8 or Cloudflare's 1.1, 1.1. Like any critical piece of internet infrastructure, DNS can be a target for bad actors. Traditional DNS queries are sent in plain text, which means they can be intercepted and even modified by someone on the same network. This can lead to attacks where a user is redirected to a malicious website instead of the one they intended to visit. To combat this, newer, more secure protocols have been developed. One of the most important is DNS over HTTPs, or DO. DO encrypts your DNS queries, wrapping them in the same secure HTTPS protocol that protects your online banking and shopping. This makes it much harder for attackers to spy on your browsing habits or hijack your connection. Many modern browsers and operating systems are now adopting DO to make the internet a safer place for everyone. So let's recap this incredible journey. DNS is the internet's phone book, translating the domain names we remember into the IP addresses computers use. It operates on a smart hierarchical system, starting from root servers, moving to TLD servers, and ending in authoritative name servers, which hold the final answer. To make this process lightning fast, Catching stores recent lookups, so we don't have to repeat the journey every time. Your ISP's DNS resolver does all the hard work of chasing down the IP address for you. And as the internet evolves, security measures like DNS over HTTPS are being implemented to protect our queries from prying eyes. It's an elegant, resilient, and absolutely essential system that works silently in the background. It's making the internet accessible and easy to use for billions of people around the globe. The next time you effortlessly browse from one site to another, take a moment to appreciate the incredible, invisible work of the domain name system. It's a masterpiece of distributed engineering that truly holds our digital world together. Thanks so much for watching. If you found this explanation helpful, please give this video a thumbs up. And don't forget to subscribe for more deep dives into the technology that powers our world. See you in the next one.